Hello guys, we will explain about ultraviolet visible spectroscopy in this video. My name is Dhines and I will explain about the working principle of ultraviolet visible spectroscopy. Before that, let we see the definition of ultraviolet visible spectroscopy. Ultraviolet visible spectroscopy is an analytical technique that measures the amount of discrete wavelengths of ultraviolet or visible light that are absorbed by or transmitted through a sample in comparison to a reference or black sample. Let us see the principle of ultraviolet visible spectroscopy. It is based on the observation of ultraviolet light or visible light by chemical compounds, which results in the production of distinct spectra. Spectroscopy is also based on the interaction between light and matter. When the matter absorbs the light, it undergoes excitation and de-excitation, resulting in the production of a spectrum. When matter absorbs ultraviolet radiation, the electrons present in it undergo excitation. This causes them to jump from a ground state, which is an energy state with relatively small amount of energy associated with it, to an excited state, which is also an energy state but with a relatively large amount of energy associated with it. It is important to note that the difference in the energies of the ground state and the excited state of electron is always equal to the amount of ultraviolet radiation or visible radiation absorbed by it. That's all from me.
Hello, my name is Nabila Aisyah and I will talk about the application of ultraviolet visible spectroscopy. UV visible spectroscopy is widely used in the field of analytical chemistry, especially during the quantitative analysis of a specific analyte. For example, the quantitative analysis of a transition metal ions can be achieved with the help of UV visible spectroscopy. Furthermore, the quantitative analysis of conjugate organic compounds can also be done with the help of UV visible spectroscopy. It can also be noted that this type of spectroscopy can also be carried out on solid and gaseous analytes in some conditions. So there are several applications of UV-Vis, but here I attach the main two, which is the first one is the absorption of a reactant or product at constant wavelength provides a means of monitoring the progress of a chemical reaction. Clinical studies using indirect measurement of reaction is characterized by enzymes can also be carried out. DNA or deoxyribonucleic acid are involved in protein synthesis in living cells and preserve genetic information. Changes in pH or heating can lead to denaturation with the resultant increase in absorption at 260 nanometer. Monitoring absorption at this wavelength is useful for denaturation monitoring. Other than two applications that I stated before, these are some other applications that we can know and understand. The scope of the application of UV-Vis spectroscopy is fast expanding and new applications are daily reported. The simplicity, accuracy and cost effectiveness contribute to its popularity in areas such as pharmaceuticals, life science, foods, environmental studies, forensic and mineralogy. Today, it is difficult to imagine a laboratory that is not equipped with a UV-Vis spectrophotometer.
To prepare the sample, we'll take our cuvette and of course pour out the blank solution. Next, I'm going to add just a drop or two of the solution used in the IR experiment. Now let's collect our spectrum using the sample that we created, a name that you can identify as your own. After clicking OK, the experiment will begin, and you'll be able to watch your spectrum collect in real time. Here I've grabbed the bar to drag down my information window so I can see the spectrum a bit better.
So that's all from our group. Thank you very much.